Hello, this is Fatih Furkan Erkeç, and I'm going to ask ChatGPT, can you give me a basic practice question on Radix sort with base R? And here is our results. Consider the following list of positive integers. Perform a single pass of Radix with base R10. Showed intermediate results after each pass. But he gives us a solution. Let me ask, can you give me another one? Okay, consider the following list of positive integers. Perform a single pass of Radix sort with base R10. Showed intermediate result after each pass. Okay, pass 1. Let me copy the bucket from here. On pass 1 we have okay. Let me write this down real quick, and after that I will continue the video. Okay, I write the first two passes. In pass 1 we have 891 in bucket 1, 453 in bucket 3, 564 in bucket 4, 327 in bucket 7, 678 in bucket 8, and 209 in bucket 9. And intermediate result after pass 1 is like that. After pass 2 we check the second least significant digit, and after the pass 2 we have these results, which is already sorted, but in pass 3 we should do pass 3 because the algorithm doesn't know if those are sorted or not without checking the last digit. So let me clear the boxes, and in pass 3 we check the third digit, and if we look at that we have 209 for bucket 2, 327 in bucket 3, 453 in bucket 4, 564 in bucket 5, 678 in bucket 6, and 891 in bucket 8. And after the intermediate result after pass 3 is same as pass 2, which is sorted, and let's check if it is correct. Okay, it seems you have provided the solution along with the intermediate results for each pass of Radix sort. If you intended to share the solution, that's great. If you were looking for the solution to be withheld so that others can attempt the problem, let me know and I can provide version without the solution. Let's talk about the first question, but after that we said, can you give me another question without the solution? And here is the solution of that question. Okay, thank you for listening. Now we will ask ChatGPT, can you give me a basic practice question on analyzing running time of Radix sort algorithm to sort n integers in the range to 1 to n over 2. Okay, the question, suppose you are given an array A of n integers, each in the range from 1 to n squared. You decide to use Radix sort to sort this array. The Radix sort algorithm sorts the integers based on their digits, starting from the least significant digit to most significant digit. Each digit is assumed to be in the range from 1 to n squared. What is the maximum number of digits each integer can have in this scenario? For each digit, the Radix sort algorithm takes O n time to sort. Given the maximum number of digits from part A, what is the overall running time of Radix sort algorithm in terms of n? Compare the running time of Radix sort in the scenario to the running time of a comparison-based sorting algorithm such as merge sort or quicksort in terms of their big O complexities. And we have a hint in here. Recall that the running time of Radix sort is often expressed as O d times n plus k, where d is the number of digits and k is the radix maximum value of a digit. Okay, let me think about this question a little bit and I will continue the video. Let's solve the question. For A, ChatGPT asks, what is the maximum number of digits each integer can have in this scenario? In this scenario, each integer range from each integer in the array range from 1 to n squared. The maximum number of digits each integer can have is equal to the maximum number of digits each integer can have is equal to the number of digits in the base n squared equal to the number of digits in the base and or to represents of the largest number in the array. So the largest number in the array is n squared, and its base is n squared. Representation has only one digit, which is 1. Therefore, the maximum number of digits each integer can have is 1. Let's write it. Largest number in the array is n squared, and its base n squared representation of space n squared representation has only one digit, and which is 1, and therefore the maximum number of digits each integer can have is 1. So in B part, since the maximum number of digits each integer can have is 1, as we determined in part A, the overall running time of the Radix sort algorithm in terms of n is OD times n plus k equals to O1 1 times m plus n over 2, which is equal to O n squared, I think. Let me check real quick. Yes, I think that's the answer. So let me write this. Since the maximum number of digits each integer can have is 1, the overall running time of the Radix sort algorithm in terms of n is O 1 times 1 times n plus n squared. So, and this is equals to O n squared. And for the C parts, the running time of the Radix sort in this scenario is O n squared, and comparison based sorting algorithms like merge sort or quick sort have a lower bound of omega n log n, and therefore in terms of big O complexity, Radix sort in this scenario is less efficient than comparison based sorting algorithms when n is large, as n squared is greater than n log n. So let's write it here. Running time of Radix sort in this scenario is O n squared comparison based sorting algorithms like merge sort or quick sort have a lower bound of O omega n log n for their running time. So in terms of big O complexity, Radix sort in this scenario is less efficient than comparison equation. Comparison based sorting algorithms when n is large, as n squared is greater than n log n. Okay, let's sum this. Okay. So our analysis is correct, and ABC, every answer of is correct, and there is no other question to ask to ChatGPT. This video is over. Thank you for watching.